Now let me turn to examples of the power of the digital twin with 3D experience with 4 examples. 3D printing of the tallest additively manufactured structure in the world, lightweighting electric automotive vehicles for the future, weight and cost reduction of thrust reverser blocker door for a gas turbine jet engine, and virtual twins of the Large Hadron Collider support structures for CERN. Additive manufacturing at large scale has been realized in Indiana at Thermwood Corporation, founded in Dale, Indiana in 1969. Thermwood is developing the future machine tool industry for large-scale additive manufacturing with extrusion deposition of carbon fiber reinforced thermoplastic polymer composites. Unlike desktop 3D printers, the Thermwood LSAM can produce products with dimensions measured in meters rather than millimeters. 3D printing of carbon fiber-filled polymers involves complex multi-physics processes that are simulated in a digital twin of the process, additive 3D, developed by Purdue-CMSC on the Abacus 3DX platform. By creating the digital twin of the manufacturing process and using this information to describe the transient state of the printed geometry, the outcomes of the printing process and consequences in performance can be predicted before the physical print begins. Unsuccessful and unfavorable designs can be discovered in silico without expending material, machine time, and operator effort. Additive 3D offers designers and machine operators access to the ability to utilize the full multi-physics simulation capability for the EDM process in a standalone fashion, requiring no expertise in finite element software or computer programming. Goal of Additive 3D and the simulation workflow presented herein is to bring the power of the simulation to the additive manufacturing community. The integrated nature of the Additive 3D workflow also presents a platform for leveraging machine learning to future explore material, machine, and part design. Issues such as layer adhesion and thermal deformation during the post-printing can be addressed. The impressive Las Vegas Raiders Stadium torch is considered to be the tallest additively manufactured structure in the world. The CMSC created the digital twin of the performance of this giant structure when subjected to the natural loads from wind and self-weight in order to guide the design engineers in ensuring its safe performance when located in the stadium and while under construction. The 3D printed structure was installed in the new stadium of the Las Vegas Raiders, a National Football League team. The memorial torch is 9 stories tall. It was installed at the newly built Allegiant Stadium. Reportedly, it took 50,000 man-hours in total to design, manufacture, and erect the impressive additively manufactured structure. The 3D printed torch consists of as many as 225 additively manufactured blocks, with each one weighing approximately 350 pounds. The blocks were 3D printed on a large format Thermwood LSAM machine that Dimensional Innovations acquired from Thermwood in 2019. The company chose carbon fiber reinforced polycarbonate composite for this project, and more than 100,000 pounds of this raw material were required to fabricate all of the blocks.